Okay, so let's look at number 1 together. It says we're going to solve each equation, and I have 2 to the x equals 32. So when you look at this, what are you thinking? What is there anything that jumps out at you? Like, what do you know?
4.
What?
Shouldn't x be 4?
X would be 4. How do you get 4?
12.
What's 2 to the 4? 2, 4, 8, 16.
Oh.
But you have the right idea. Rachel?
It's 2 to 5.
It's 2 to the 5. Well, okay. On the right side, isn't that 2 to the 5? And so if you can get their bases to be the same, x is 5. Alright, how about number 2? ln x minus ln 3 equals 0. So we did this last year in Algebra 2. What might we do? Emily, what do you think?
Could it be ln 3?
You can add the ln 3 to both sides, and then their insides are equal. Alright, how about number 3? 1/3 to the x equals 9. Any ideas, John?
Would it be -2?
It is -2, but what are you thinking? How are you doing it?
You get 9 to the -2 power, and then you set the x equals 2 because the two exponents are equal.
Okay, wait a minute, I'm not following you. Where would 9 to the -2 come from? I mean, you're right, okay, you are right. I'm just trying to get you to think through your thinking, if that makes sense. I mean, you don't randomly just take 9 to the -2. It's you know something, and I'm trying to get you to identify what do you know. You know that if you take 9 to the -2, well, that's going to make it 1 over, no, it's not -2, is it? I mean, x is -2, but you're not doing 9 to the -2. Sophia?
You do like 1/3 to the -2. Like, if you change 9, because you're trying to get the bases of the same, so I changed 9 to like 1/3, and then I knew that 1/3 to -2 is 9. So
Okay, say that again. You changed 9 to 1/3?
yeah, because to get the bases the same.
1/3 to the -2 is
Yeah.
9.
Yeah.
Because then it's the same base.
Yeah.
Okay.
1.
Okay. I know, but wow. I mean, that's a lot of stuff in there. So it's,
Just make the bases the same.
yeah, you're trying to get the bases the same. If 1/3 is -1 power, right? And you know 9 is 3 squared. And if you remember your exponent property, this will give me -x equals 2, so x is -2. I mean, I'm trying to think of if somebody's confused, how are they going to follow? You're trying to get,
Same base.
yeah, you're trying to get the same base, but you're 1/3. You know you want it negative to make it 3, and you know you need 3 squared to make it 9. Is that what you mean?
Yeah.
Okay, all right. And that's wonderful for those of you that can do that in your head, and continue to do that. That's terrific. But I'm trying to think of the students that they're like, what? What are you doing? So you do. The goal is you want to get the bases to be the same. Well, I can do that by understanding that 1 divided by 3 is 3 to the -1. And then you've got to use this exponent property that says a to the m to the n. You multiply those, so that's where my -x comes in. Now, I do want to mention that we're not canceling the bases. I don't want anybody to think that that's what we're doing. We are not canceling those 3's. But what we do know is if you have the same bases, the exponents are equal. Okay? All right, how about number 4? E to the x equals how might we solve this one? Anybody remember?
Are you gonna log like the other form?
Yeah, to go from exponential to logarithmic form, if it's base e, that's ln 7, and it equals the exponent, and in this case that's an x. So depending on what part of a quiz or a test that you have, if you have no calculator, x equals ln 7 is your answer. If it's the calculator part and it says round to decimals, we would then say x is about, and I said 1.95. So depending on your circumstances, how you might write your answer. All right, how about number 5? ln x equals negative 3. You guys remember this from last year, Tyler?
You put it in exponential form, which would be e to the negative third equals x, so x equals 1 over e to the third.
Good job. Okay, and depending on whether you have your calculator or not, e to the negative 3, we would never leave a negative exponent, so it's 1 over e cubed. So what I want to point out with number 4 and number 5 is that when in doubt, go from exponential to logarithmic form or logarithmic form to exponential form. Anytime you feel stuck, that would be a good strategy. Okay? All right, then we're going to use that same strategy in number 6. If I have log x base 10 equals negative 1, I'm going to go to exponential form, and that would be 10 to the negative 1 equals x. So x is 1/10. All right, number 7 is just like number 4 above it. This is going to go ln 72 equals x. And you would either leave it like that or do a decimal. All right, now number 8 is really going to fine tune whether we understand what we're doing. If I have 3 times the quantity, 2 to the x equals 42. Can I say that's, can I multiply 3 times 2 and say that's 6 to the x? Okay, let's say we're not sure. Say you're thinking, I'm going to try that out. I don't know any property that says that, but I'm going to try it. And so here's what you want to do. If you think that's 6 to the x, pick a number. Let's say, we'll not do it too large, but let's say x is 2. And so this would be 3 times 2 squared, 3 times 4 is 12. Do you see that's not true? And there is no such property, and we should know better from order of operations. 2 to the x power, you'd have to do the exponent before you could do any outer multiplication. So I don't know what x is, so I can't try to combine them that way. So you guys, if you're trying to do something and you're not 100% sure that it's the distributive property, commutative property, and exponent property, if you are not sure and you're testing it out, go off to the side, write out what you're trying, plug a number in. If it doesn't work, you can't do that, okay? All right, so let me erase this. It was good to think about. All right, so if I can't take 3 times 2 to the x, what else can I do? Divide both sides by 3. And I get 2 to the x equals 14. All right, now it's similar to number 1 and number 4 in that my unknown, my variable's in the exponent. But it's different from number 1 in that, okay, I can't think of 2 to some power that's going to give me 14. It's more like number 4 where I have to go to logarithmic form. So this is going to be log 14 base 2 equals x. And I have a bit of good news for those of you that have TI 83s. Tomorrow I'm going to snag Scott's calculator, and I had him write a program for you that will do change of base. So since your calculator doesn't do it, he's really good with programming. So he wrote that. I'll bring it tomorrow. So if you have the 83, and even if you have an 84 that has an older operating system, mine's actually, I don't know what happened to my personal one, but it somehow doesn't have the change of base on it right now or something. So, if you have a TI-84, I can try to upgrade your operating system. If you have an 84, it won't work with the 83s. Okay, so if you have the older calculator, do ln14 divided by ln2. If you have the newer one, you can just enter it, and I went 2 places, so it's about 3.81. Okay, so remember, before you can go to logarithmic form, you actually have to have the exponential part alone. No addition to it, subtraction, or multiplication on it. Alright, then let's try number 9. What would you need to do first here if you have e to the x plus 5 equals 60?
Subtract 5.
Good, subtract the 5. And now we can just go to logarithmic form. Now this does say round to decimals, so let's practice using our calculators. So I'm getting x is about 4.01. I'll give you a head start on me. I want you to try number 10. I'll give you a few minutes. Now remember, you have a calculator. So I'm going to add 4, divide by 2, and I have 3 to the 2t minus 5 equals 7.5. Alright, what do I do?
Do log form.
Put it in logarithmic form. So this is going to be log 7.5 base 3 equals 2t minus 5. And so do you guys realize that on the left, I can figure that out. I know the log of 7.5 base 3. And I'm getting 1.83. Then you're going to add 5 to both sides. And then divide by 2. And I got 3.42. Any questions on how you do problem 10? Anything? Alright, then let's look at number 11. It says solve using factoring. Okay, it's e to the 2x minus 3 e to the x plus 2 equals 0. And I don't know if you remember this type from last year or not. But let me go ahead and set it up and then work backwards to explain how I did what I did. I need to refresh your memory from an exponent property that says if you take a to the m times a to the n, that's a to the m plus n power, right? You know that back from Algebra 1. Well, guess what? E to the x times e to the x means e to the x plus x. Well, x plus x is 2x, so that's how I did this. I did e to the x times e to the x is e to the 2x. The outer is minus 2 e to the x. The inner is minus 1 e to the x. Negative 1 times negative 2 is 2. Then you're going to use the zero factor property that says that's e to the x minus 1 is 0 or e to the x minus 2 equals 0. So this is ln1 equals x, but I know ln1 is 0. E to the x equals 2, so that's ln2 equals x. And you either leave it like that or put it in a decimal form, depending on which part of a quiz or test you have. All right, number 12, ln x equals 2. I'm going to rewrite this as e to the 2 equals x. And we can just leave it like that, e squared. A note I need to remind you of from last year. You must check domain in a logarithmic equation. Because if you remember domain of a logarithm, the inside of the logarithm can only be positive. It can't be 0 or a negative. So if I plug in e squared, okay, e squared is positive, so it's okay. And you're going to see eventually where we might run into a problem. In number 13, how would we solve this one?
So what's inside the parentheses for each other?
Yeah, do you understand? If you have a log on both sides with nothing else, their insides are equal. So this becomes 4x equals 8. X is 2, and I check the domain. 5 times 2 is 10. 10 minus 1 is 9. It's okay to have a 9 inside. 2 plus 7 is 9. That's okay. Number 14, if I have 2 times the log of 3x base 5 equals 4. I cannot rewrite this in exponential form because the logarithm's not alone. So you can divide by 2 and get the log of 3x base 5 equals 2. And so 5 squared equals 3x. So x is 25/3. Remember to check your domain, that's okay. Now there was a second way to solve this one. Was there anybody else who was starting it and thought, oops, I was going to do it a different way? Tyler?
I think so. I took the 2 and then made it like 3x in parentheses squared, so then you get 9x squared equals 4, and then you switch it to exponential and get 5 to the 4th equals 9x squared, and then I stopped because you did something different.
Okay. All right. And I like, though, that you did it differently, or you were going to do it differently. The problem, and you can do it this way, okay? You can do it, and there's nothing wrong with it. This is 25/3. It's plus or minus. You understand that? When you bring that exponent up, and it's an even exponent, now you've created 2 answers. And so the reason why I said, hey, remember the note, if I tried to plug in negative 25/3, that's the log of negative 25. I can't have a log of negative 25. So as long as I'm checking my domain, it doesn't matter which method I use. They're both good ways to do that. Okay? All right, number 15. I'm going to give you a head start on me. I want you to solve this equation and round your answer to 2 decimals. Okay, you start by subtracting 5, divide by 2. You have ln x equals negative 1/2, and then you rewrite it in exponential form. E to the negative 1/2 is x. You just punch that in your calculator, and I got about 0.61. Any questions? All right, number 16. I have log 5x plus log x minus 1 equals 2. All right, I cannot set their insides equal. And I cannot get one log on each side. If I subtract a log, I've got 2 minus a log. So again, I'm stuck. Thinking back to what we did in the previous section, what might we be able to do here? Condense. Good job. You want to condense and say, and also notice I'm going to drop the base 10 because I know if there's no base, it's understood to be base 10. So I can condense this, and now I have a log that equals a number, and I can go from logarithmic form to exponential form. And if you think back to my extra credit problems on the last chapter, I kept putting them and putting them. Some of you just said 5x, x minus 1 equals 2, and you just dropped logs. Hopefully now you remember what to do here. So I'm getting a quadratic equation. My first plan of attack with a quadratic equation when I want to solve it is to try to factor it. Because it's an equation, I can divide by that GCF and make it x squared minus x minus 20. This factors nicely. So I'm getting x minus 5 times x plus 4. Check your papers. Make sure you don't lose your equation. Every line below should be equivalent to the line above it. So you can't go from an equation to an expression. I mean, that's not okay. Now, I'm not finished. You have to check your domain. If I plug in 5, 5 times 5 is 25. I'm allowed to have a positive number inside the log. 5 minus 1 is 4. I can have a 4 inside the log. If I plug in negative 4, 5 times negative 4 is negative 20. That's not allowed. I don't need to waste my time checking it in the second one. If it doesn't work in one of the two, I cannot do it. So don't waste your time thinking, oh, I'm going to go check over there too. You know it doesn't work, so don't do it, okay? All right, any questions on this? So if you have more than one log, addition or subtraction, so there's a group of these in your homework, but tomorrow when you work on the worksheet, you'll see lots of practice for it. Okay, now the last example, it says you have deposited $500 in an account that pays 6.75% interest, compounded continuously. How long will it take to double your money? All right, so let's play the game. What do I know? All right, so tell me one thing you know about the problem.
You deposited $500.
Okay, you deposited $500, so that's the amount you're putting in. John?
You're trying to find out how to get $1,000.
Ooh, good. You're trying to double your money. They didn't come out and say it explicitly, but we can figure out we want it to grow to $1,000. Okay. I was hoping we would have said something else first, but it's okay. What else do you know?
The rate.
Okay, I know the rate. Still know what I'm going for.
We know
PERT. Okay, that's what I needed. I
Sorry,
needed
was plugging
PERT.
buttons.
I needed the PERT. Okay. So then now you've told me everything else. So I wanted to grow to $1,000. We started with 500 and we knew the rate. Okay, so there we go. We had all the pieces there. And it's okay to do that where you start writing some things down and then you're like, okay, I don't have an equation. There's usually some sort of equation that we're going to work with. All right, so let's divide by 500. And I get 2 equals e to the 0.0675 t power. All right, now this shouldn't seem so strange to us as to how on earth are you going to solve it based on what we've done. If you have an exponential equation where the variable's in the exponent, we just go to logarithmic form. If it's logarithmic and the variable's inside, you go to exponential. So you're just going to flip between the two. So this is going to be ln 2 equals 0.0675t. Well, I can figure out ln 2, punch it in your calculator, and then you're going to divide by 0.0675. and I'm getting about 10.3 years. See if you can get that. Now, I want to do one extra problem with you. Hopefully you have enough space. Is when you're doing things like this and it's compounded continuously and you double or triple your money, you can actually figure out how long it will double or triple without knowing the starting amount that you put in. Watch this, okay? It's really, really neat. Okay. You want to triple your money at 4% compounded continuously. How long will it take? Okay, I gave you no money whatsoever. But the fascinating thing is we can figure this out. So you start with PERT. If you say I put P amount in, if you triple it, what would that look like?
3p.
3p. So I have 3p equals p times e to the 0.04t power. And then what's so neat is that if I divide by p, I didn't need to know it. Do you see that? That on your homework, you're going to be asked to do this, and I always have a student who says, well, they didn't give us the amount. You really don't need it, because you can call the initial amount p, but if you want to quadruple it, it's going to end as 4 times p. And then the p's will cancel. So then let's finish this. This will be ln 3 equals 0.04t. So grab your calculators and take ln 3 divided by 0.04. So no matter what you put in the bank, if you want to triple the amount at 4%, it's going to take you 27 and a half years.
Yeah.
That's actually really good if you think about it.